I'd like to thank you for joining us for today's webinar, How to Accelerate Genomics Data Analysis Pipelines by 10x. My name is Jennifer, and I will be your moderator for today's event. We have two great speakers with us today. I'd like to introduce Shailesh Manjrekar, Head of AI and Strategic Alliances with WekaIO. Welcome, Shailesh. Can you please give the audience a little background on Weka?
Thanks, Jen. Good morning, good afternoon, good evening, folks, wherever you are in the world. Thanks for joining us today. I head AI and Strategic Alliances for Weka. We are based here right in Silicon Valley with engineering offices in Israel. Genomics is one of our forefront use cases, and we work with marquee customers, and we'll walk you through as we go along through the presentation.
Perfect. Thank you. I'd also like to introduce John Torr, CMO at Cloudian. John, can you provide a little background on Cloudian for our viewers?
Hello, everyone. This is John Torr. Thank you very much for joining. And Cloudian is an enterprise storage company. We are also based here in Silicon Valley, just north of where Weka is located. And we are in the object storage business. So we are S3 compatible object storage on-prem in your data center. We are the capacity tier that complements the Weka front end, and we look forward to telling you more.
Perfect. Thank you. And with that, I am going to pass it off to Shailesh.
All right. Folks, COVID-19 pandemic has really put life sciences as a discipline on the forefront. I'm sure all of you guys have been aware of it and have been associated with it in one form or the other. In fact, this COVID-19 pandemic was predicted by Bill Gates back in 2015 in one of the TED Talks, and still we were caught by surprise when it really happened. So we decided to take this opportunity to take a step back, understand where life sciences as a discipline has made advancements and where there are still gaps, particularly on the technology side, and how we can help fill those gaps or mitigate those gaps. So as you guys know, life sciences certainly has made advancements multifold. Scientists are now able to understand DNA and RNA variations, research drugs, understand biomarkers, and personalized treatments to a great degree. Having said that, what we are seeing is as you get to the secondary and tertiary analysis, technology is becoming a bottleneck. And that's primarily the topic for today's discussion. So what we'll talk about is give you a little background around life sciences applications, what we encounter. We'll talk about business challenges, particularly associated with the data deluge. We'll talk about what is a solution that we are proposing working with our esteemed partner, Cloudian. So we are essentially, Weka is an next generation all-flash parallel file system and formulates the performance tier for the storage part of the solution. And then Cloudian forms the capacity tier with the object economics and the durability. So we'll talk about the better together story. And then finally, we'll leave you some pointers as to how to reach out to us and so on. So with that, some of the use cases, what we encounter is omics sequencing is certainly on the forefront. It can be for whole genome, exome, or RNA processing, and particularly what we call next generation sequencing is one of the prominent use cases, what we see. The second use case we see is around bioimaging, where we see the likes of light sheet microscope, cryo-EM microscopes, digital pathology, and so on. We also see molecular dynamic applications like, some of the common names are around Amber and Gromax and so on. And then finally, we see clinical diagnostic applications where, there's a heavy use of artifacts like PACS and X-ray and CT scans and MRI. And as we go along, we are seeing the advent of machine learning and AI, artificial intelligence, and what we tend to call it augmented intelligence, right? Because it's not artificial intelligence on its own. There's always human intervention. There's always human supervision associated with that. So we're seeing advent of those technologies a lot happening in these disciplines, and we'll talk about that as we go along. So a little bit on the workflows. Again, some of you may be very familiar with this workflows, but if you look at the next generation sequencing workflows, it starts with the sequencing machines of the likes of, sequencers from Illumina, which have become now, which have made great technology strides and are able to process this sequencing at an incredible speed. But essentially from there, you do the BCL to FASTQ conversion from those genome sequencer files. And FASTQ files are then used for what we call base pair alignments and sequence alignment mapping and binary alignment mapping. And then finally, they get into what we call variant calling phase, where you are essentially looking at the variance between the reference genome and the sequence genome. Okay, so that's kind of the workflow. And in fact, we start with the FASTQ files, which are fairly large files, and then eventually get into smaller files. Versus if you compare that with the bioimaging workflow, it actually starts with smaller files. And these are primarily images coming out of cryo-EM or light sheet microscopes. These are essentially images, but there is data amplification which happens with these images, and those file sizes grow extremely large. Okay, in fact, the cryo-EM microscopes almost spit out about 2 terabyte of data sets per day. Light sheet microscope spit out about 25 terabyte of data sets per week. So humongous amount of data sets coming out of these 2D and 3D images, which are used for electronic microscopy. So let's look at the business challenges. So first and foremost, as I said, the data deluge is what all life science folks are struggling with. There is so much of data coming from all these data sources, and it's really becoming a challenge to derive actionable intelligence out of this data, operationalize this data set, and then finally also provide governance on these data sets, because these are really regulated use cases pertaining to all personas, and you got to make sure that there is security, there is the proper governance, and so on. So that's the first challenge, what we are seeing with data almost doubling every 7 months, and it's predicted to be at 40 exabytes by 2025. The second challenge, obviously, is a race to get products to market. And I'm sure you guys hearing this with the vaccine development, particularly for COVID-19. Everybody is heads down trying to be the first to market. And the last problem, not the least, is essentially managing and protecting these data sets, particularly at this scale. So, the conventional technologies like, taking snapshots and so on are becoming very unpopular when you're talking about that scale of data set. So one of our publicly talked customer is Genomics England, and if you know Genomics England, they are being tasked for the 5 million genome project in UK, and they chose us. It's a publicly talked case study for us, and kind of there was an existing vendor who could not fulfill their data capabilities. So if you see this graph, they are right now at about 500,000 genomes, and they're predicting to get to 5 million genomes by 2023. And associated with that, the data set is predicted to go from 40 petabytes today all the way up to 140 petabytes. So they replaced the existing vendor, which comprised of 144 nodes and could only scale up to 20 petabytes. And they replaced us with that existing vendor. And now we are able to meet their scaling as well as performance requirements. It's a very high profile customer for us, okay, and publicly talked about and so on. Okay, with that, I will invite John. Hey, John, with that data deluge, what are you folks seeing in terms of how much of data resides on the private cloud versus public cloud, and what are the reasons behind that? Can you add some color to that?
Yeah, sure. This is a good time to just comment on the overall challenges of managing that scale of data, because you commented on where that data is coming from and how it gets amplified throughout the process. And what's happening is it's creating petabytes of data on the back end, which frankly, today's conventional storage architectures for file and block were not really designed to accommodate. They were really designed to accommodate up to a petabyte and maybe small numbers of petabytes. When you get beyond that, it really takes a different kind of storage architecture. Fortunately, we have object storage, which was a storage technology that was designed for the public cloud. So Google, AWS, Microsoft Azure are all built on the object storage technology, that architecture. Well, that exact same architecture can be used in your own data center as well on-prem. And there's a number of advantages to that. We'll talk about those advantages a little bit later on. But just to give a flavor of this, it's a scalable storage architecture that grows within a single environment. So it starts simple and it stays simple. The other thing that's really important about object storage versus other storage types is cloud integration, because everybody needs to have cloud as part of their overall storage strategy. It's just too important a part of the overall landscape to leave out. And it can play a very important role in, for example, providing a backup target or a DR target, a place to keep a copy of your data off-prem where it's safe elsewhere. You don't necessarily want to use that for your active data because it's slower to access and it has other downsides. But as a backup target, it's extremely useful. So the public cloud and private clouds need to work together, and object storage and Cloudian are terrific at that. We work with Amazon, we work with Google, we work with Azure, and because we all speak the same language, that interface between the two of them is seamless. So these two things, the ability to store large amounts of capacity and the ability to integrate with the public cloud are two of the things that set apart Cloudian storage from more conventional file and block. And I'll go into this in a little bit more detail later on in the talk after you talk through, what Weka is doing on the front end.
Great, thanks, John. So again, to kind of reiterate, what we are saying is earlier, the sequencing part or genotyping part used to comprise almost 90% of the time through the pipeline, and the interpretation or the secondary or tertiary analysis, what we call, used to be a relatively smaller part. Now we are seeing that it's exactly the opposite. The sequencing machines have become so much faster, and the genotyping has really made several technological advancements. And the information technology part, as it pertains to the secondary and tertiary analysis, is what is really becoming the bottleneck. Okay, so we'll talk about several value propositions, what we bring to the table, and the trends, what we are seeing with this. So other challenges associated with these pipelines is the kind of data sets is very unpredictable, and it's kind of pretty much you'll see all kind of variations when it comes to these data sets. So there are several applications, right? I'm sure you guys are familiar with BLAST, which essentially uses flat file databases, and it's considered the Google for life sciences. So that's one kind of an application. You see CryoSpark, you see Reliant, you see a multitude of these applications, and each of them have different storage patterns. So also the data sets or the files coming out of the cryo-EM microscope, for example, these are several million small files created and deleted. The next generation sequencing has several gigabyte worth of data stores. All has to be in a single global namespace. Also, another requirement is millions of these files have to be created in a single directory, which pertains to particularly one genome processing. And then the files can vary from almost 30 kilobyte all the way up to gigabytes. And as I alluded to earlier, each of these devices, like an cryo-EM microscope, can spit out about 2 terabytes of data set per day. So you can imagine the kind of deluge of this data set across the pipeline, and how this data sets are posing challenges to these pipelines. Okay, one of the important trends, what we are seeing here, is really with GPU acceleration, or what we call essentially the advent of technologies like AI, machine learning, and deep learning with these workflows. One of the things which has happened is, with the advent of GPUs, suddenly the parallelism in the compute layer has gone up almost tenfold. So in the previous days, largely CPUs used to be used for this pipeline processing, and a typical Skylake or a Cascade processor used to comprise of about 24 to 48 threads. Now, when you get to a GPU from either NVIDIA or one of the GPU server vendors, you'll see that a single Tesla V100 comprises of 5,000 cores or 5,000 threads. So the amount of parallelism in the compute layer has gone up significantly, and the compute layer is now able to provide almost petaflops of compute power. So what this does to the storage is really the traditional storage stack comprising of NFS and the older technologies just falls short when it comes to feeding data to this massively parallel compute layer and pipelines. That's where you need to redesign and rethink your storage architectures, and that's the reason why Weka, with its parallelism, built-in parallelism, all the way from NVMe flash all the way throughout the stack, is really emerging as an ideal solution for this kind of architecture. Okay, so planning for next wave of discovery really needs a radical departure from status quo. Okay? We have a quote from one of the CIOs who has been on the forefront of this. Okay, so the new technologies you would see around AI, machine learning, natural language processing, blockchain, and other emerging technologies becoming a big part of these pipelines. So just to kind of give you a little sense of where we are seeing AI ML penetration with these pipelines, let's start with genomics as an use case. And we see a lot of GPU acceleration happening with this use case. A case in point is a solution we have put forth with Parabricks. Parabricks, if you know, it was a startup which NVIDIA recently bought about 4 months back. And what Parabricks does, it accelerates the traditional GATK toolkit from Broad Institute. It accelerates it for GPUs. Okay, almost by a 10 to 20-fold acceleration you can associate with Parabricks. And what we have done is we have put forth an reference architecture working with Parabricks on GPU servers, and that solution brief is available to download from one of our channel partners. But that's an example of how we are seeing this compute layer transforming. Another example is Edico Genome, which was a startup Illumina bought somewhere in around 2018, and now they are that product, the Dragon product, has become part of Illumina's portfolio. But that's an compute layer comprising of FPGAs, okay, primarily targeted for secondary analysis. So you would see lots and lots of these technologies, whether it be GPUs, whether it be FPGAs, now utilized to make that compute layer extremely parallel and faster. Okay, and that's what is driving the pressure on the traditional storage technologies. Another example where we see AI ML being heavily used is for clinical diagnostics. So the artifacts like CT scans, X-rays, and MRIs are actually being used for anomaly detection. There are AI ML pipelines being run on top of this, where you are able to predict the likelihood of a patient getting, for example, say COVID-19, just looking at the MRIs and CT scans or X-rays. Okay, and there are deep neural networks which can do this extremely well under human supervision, and that's what we call actually augmented intelligence. There's a big use of technologies like transfer learning and federated learning being used because the learning part or the training part of these DNNs becomes an important aspect of this new AI ML pipelines. The third use case where we see AI ML being used is for cryo-EM data selection and classification for drug discovery. So as you guys know, cryo-EM pipelines are primarily used by pharma and drug companies for drug discovery. And CNNs, or what we call convolution neural networks, are used heavily to eliminate false positives with the 3D image analysis. Similarly, DNNs, or deep neural networks, are used to predict protein structures and then predict as to how these protein structures can bind to a protein of a pathogen. like COVID-19. Okay, so heavily AI ML has been increasingly used for these use cases. And because of that, what Weka has decided to do is obviously we are the custodians of the data set, which is the most strategic asset for life science companies, right? Which is what you base your diagnosis on. So we are at the center stage of this reference architecture. But having said that, we also understand that there are other components which play an important role. So we work increasingly with accelerated computing vendors, like whether it be NVIDIA, whether it be HP, whether it be Supermicro. And then we work with orchestration layers, like whether it be Kubernetes from OpenShift and so on, with accelerated open source libraries like Rapids and ETL processing and so on. And then we use SDKs. As I said, we work with really SDKs focused on solving a particular vertical problem. A good example of that was Parabricks. Clara is another SDK from NVIDIA, which is primarily used for PACS diagnostics, clinical diagnostics. Okay, and there are several other partnerships what we have forged along, like Velohai, which does deep learning pipeline management systems. So now you have a single kind of a solution and complete end-to-end solution blueprint where you can do your data ingestion. You can use TensorFlow. You can use PyTorch for your AI ML processing. You can do data transformation. You can do hyperparameter optimization, and then finally you can do what we call inferencing to be able to do those predictions, so you don't have to run real trials. So this is a very powerful kind of a solution stack what we have built, and Weka AI is really industry's first software-defined solution stack. Unlike other vendors who kind of force you into vendor lock-ins and so on and so forth, what we do is we provide you the flexibility to work with the best of breed storage and compute vendors, and also vendors in the other places in the stack. Okay, so that's a framework what we have recently launched. Then coming to the actual technology aspects, this is how you would see a solution deployed between us and Cloudian. So you would have these data sets coming from precision medicine devices, IoT devices, microscopes, and so on, feeding into the fast performance tier, which is Weka parallel file system, which can provide you the highest performance and the largest scale. So we are capable of extreme scale in exabytes, at the same time able to provide you extreme performance. Okay, and we'll talk about that a little bit as we go along. And then we work with Cloudian as an object tier, which provides the cloud economics and the durability, and the management of the data between these two is managed intrinsically to the solution. Okay, the end user of the application is not exposed to the object part. What he sees is a friendly file interface, and you would see that there is the instrument ingest happening, the processing and quality control, the secondary and tertiary analysis, and then finally the life cycle management happening all end to end, and we make it as simple as possible to the end users. This is more of an technology snapshot of how the solution would look like. So on the top, you see GPU machines or GPU servers, whether they can be from the likes of NVIDIA, HP, Dell, Supermicro, and so on. In addition to that, you can look for simple clients which are actually doing the secondary and tertiary processing, or you can even connect the sequencing machines themselves, which talk either SMB or NFS directly to the storage cluster. And Weka has a multitude of deployment modes which you can use. So we can be actually deployed on the GPU servers themselves. So we run in an LXC container, and we allocate certain CPU cores for ourselves, leaving everything else for the application itself. That way you can leverage the NVMe flash built into these GPU servers, and you don't need an external storage tier. You can, from there, you can directly tier to an object store. That's one form of deployment. The second form of deployment is you can use us in what we call dedicated mode, where the storage cluster stays external to the compute tier. And that way you can, either you can scale the performance, adding additional nodes with NVMe flash, or you can uh, um, basically enhance the capacity by adding object storage nodes on the back end. And this object storage here is Cloudian, or we can also tier to an AWS environment for test day, for backup purposes, and so on. And then finally, the third mode of deployment is we also are available in AWS Marketplace. In fact, we have quite a few genomics customers using us in AWS, and our performance is pretty much on par, even in an publicly shared environment like AWS. So we are available in the marketplace, running software as a service in AWS, where customers use us for test day purposes, for wetting their feet with this new pipelines, and then eventually bringing us on-prem. So a lot of deployment flexibility, to match your requirements. At the same time, as I said, the storage servers can be from any vendor, any of our OEM partners, and we have several of those. We have very strong relationships. Some of these OEM partners resell us, and so on and so forth. Again, this is as I said, really a very tightly knit storage solution between the high performance tier and the capacity tier. So you can now scale performance and capacity independent of each other as per your needs. The NVMe flash tier, you can just add the NVMe nodes, or if you want the capacity tier, you can just add the object storage hard disk drive based nodes. Great economics. Typically, what we see is 20% of the storage tier resides on the NVMe flash for high performance, and 80% resides on the object store. And that way, we amortize the cost or the price of the NVMe flash over this hard disk drive object store tier. And then finally, as I said, protecting these data sets become an big problem for administrators. And we have extremely powerful data management capabilities. Not only are we able to provide you snapshots, and these are really next generation snapshot, what we call really memory efficient, time efficient snapshots. That means they do not occupy space. They actually just make a copy of your metadata pertaining to that data. And even more powerful capability is what we call snap to object. So this capability not only just snapshots the data, but actually also snapshots the metadata, which resides actually on the file storage. And that way we are able to create a tarball out of a file namespace. And now you can take that tarball across. You can have all the mobility you want. Take it to another object tier. You can take it to the cloud, rehydrate that file namespace there, and have another instance of Weka running there. So all those kind of data mobility options are now available because of the snap to object capability. Very, very powerful data management capability. Another thing to highlight is, as I said, the object tier and the flash tier are inherently very, very tightly integrated. And the way we do that is we keep all the metadata on the flash, and we expand the file namespace onto the object tier. What that means is, if you have 1 petabyte of a flash tier and 5 petabyte of object tier, to an application or to an user, it will look like 6 petabyte of file namespace with inode structures and everything else. Right, so the object part is completely transparent to you. You can leverage all the user friendliness of the file semantics and so on. Okay, and finally, to sum up, as I said, we leverage NVMe flash for the highest performance capabilities. We object the object tier for the capacity reasons, and bring in best of both worlds. And with that, I think I'm going to hand it over to John to talk about the private cloud capabilities of Cloudian Hyperstore.
Thank you, Shailesh. That's great. Yeah, and we provide that back-end scalable infrastructure for storing all that data. So just in brief, Cloudian is object storage, and many of you are probably already familiar with object storage. For those of you who haven't encountered this technology in your work life, you've undoubtedly encountered it in your home life, because object storage is the back end behind all the cloud services like Netflix, Facebook, Spotify, all of those are built on object storage because they had those providers had the exact problem that we're trying to solve in genomics, which is how do I effectively, cost effectively, and efficiently store large amounts of data. So object storage fills that need. It's the scalable storage infrastructure with the front end, in our case, using the S3 compatible API. So the S3 API is the language that we speak. And of course, the back end of Weka speaks S3. S3 is the language of the cloud. Cloudian provides that same technology in your own data center. So what makes us interesting in this application is the ability to grow. It's non-disruptive growth. So you grow within a single namespace, a single system. You can start small and grow to an exabyte in scale without downtime. And of course, when you're dealing with large amounts of information, cost becomes a significant concern. And here, this is really the crown jewel of the whole infrastructure is it saves you a ton of money versus any other storage type. Versus SAN and NAS, it's at least 70% less costly, 60% less costly than public cloud. We're talking costs getting down to ½ cent per gigabyte per month versus 3 to 4 times that to go into the public cloud. So when you're dealing with large amounts of information where cost becomes a real issue and how you're managing all that data, Cloudian can save you a ton of money and make that data immediately accessible on-prem in your own infrastructure. So let me just talk a little bit about the capacity part of the equation because this is kind of the starting point. Cloudian grows in this concept of nodes. We have each node is a standalone compute and storage device, but multiple nodes work together as one system. So you manage all these nodes as one system. Whether you're dealing with 1 petabyte or 50 petabytes, you're going to manage that entire environment as one system, one namespace, one set of access permissions, one set of data protection permissions, et cetera. It's very simple. It starts simple and it stays simple as you grow. Secondly, all these nodes are operating in parallel. So the parallel processing means that as you add nodes, you also add performance. This means that you don't ever get bottlenecks. And this is obviously very important when you're talking about scaling from 1 petabyte to 100 petabytes, because if you have to do migration somewhere along the way to free up a performance issue, that's going to ruin your whole day. You just want to grow simply, easily, cost effectively, and most importantly, non-disruptively. Another important part of this, what's different about object storage is that underlying storage structure with metadata that's embedded. So over time, you're going to develop information around your various objects. Obviously, in this case, they're going to have genomics information. Each object can be associated with metadata that describes what's in that object. So it can be describing different genome types or information you've learned about those samples. Whatever you want to store that helps you find that information later on can be stored in the metadata and then searched using Elasticsearch, an open source search tool that we are integrated with that provides a Google-like capability to go in and search your data and then visualize the information using Kibana. So this is very powerful to let you go in, enhance that metadata over time, find new ways of identifying specific things you're interested in, and then visualizing that data using Kibana. Extremely powerful, and this is something that object storage and Cloudian have built in, an unlimited amount of metadata per object. The other thing that's really important about this is when you're dealing with large amounts of information like this, backup becomes a real concern. Now, how do I protect the data? Well, using a traditional backup technology for 100 petabytes of information would get really cumbersome. And in many cases, all you're really looking to do is to protect it from site failure or device failure. Cloudian has that capability built in. The ability to protect that data from site failure or device failure is built in using 2 technologies, and you can use either or both together. You can replicate the data either to a Cloudian cluster at another location or to the public cloud. So you can use replication, or you can use erasure coding, which means the data can be striped across multiple locations. So you can make multiple locations all look like a single namespace, a single operating environment. Or you can do these two things together. But either way, this technology, the ability to manage the data, is built into the Cloudian environment. So there's nothing else to license, there's nothing else to manage, there's no separate software you have to load. It's all part of the basic operating environment that comes with the Cloudian device. So data protection, data search, data scaling, these are all really critical parts of managing, a large data set such as what you're going to be working with. And of course, as I mentioned earlier, the other thing that's really important about this is cloud readiness, because you're going to be using the cloud in different ways. It may be used as part of your analysis environment. It may be used as a DR environment. But the integration with cloud becomes really important. And this is another thing that's built right into the Cloudian infrastructure. Whether you're talking to a private cloud at another location, or a hybrid cloud where you're tiering data or replicating data to the public cloud, or even working across multiple clouds, Azure, AWS, Google, these capabilities, again, are all built into the Cloudian environment. So it starts simple and stays simple, even as your management environment becomes more complex, even as you're using more infrastructures. And this is very different from traditional storage, where often there's a layer of middleware that's involved in this kind of management out to the cloud environment. With Cloudian, that's all part of the base platform. It's all built in, nothing else to buy, nothing else to manage. And really, that's kind of what, a couple of the key reasons why people use this environment, why use object storage, why use Cloudian. Highest S3 API compatibility. Everything that works with AWS S3 will work with Cloudian. Hybrid multi-cloud ready. We're compatible with every cloud that's out there. Start small and grow. So you're going to start simple and stay simple. Granular management, meaning you're not locked into any particular management infrastructure. You can always change things over time to suit different needs. And that's obviously really important, because the whole point of here is you're going to create a operating environment, a storage environment that's going to stay the same over many, many years. So you want to be able to change what's going on underneath the hood to evolve to your changing needs. Object lock, meaning you can do things in a write once, read many fashion. So this is very important for compliance. If you're dealing with anything that's associated with government compliance, where medical records can't be changed over time, they can be locked using a worm technology. Data protection built in, and of course, a ½ cent per gigabyte per month cost structure, all in, including hardware, software, and support in large operating environments, which of course is exactly what we're dealing with here. This is something which is available as an appliance. So we offer either deployment mode. So if you have a preferred hardware platform, we work with any basic server environment. Most people choose highly storage-intensive servers. We don't use a lot of compute. And we offer a line of appliances on our own, which themselves are ranging from a few hundred terabytes up to 1.5 petabytes in a single device. So a tremendous range of things you can deploy to use Cloudian. And finally, it's a proven solution. On Gartner Peer Insights, we were honored with a Customer's Choice Award this year. We're the only object storage to be so honored with this award. It means we got a very high rating from our customers. We got the most reviews of any object storage platform, and we got the highest recommendation level of any object storage platform. So it's a proven solution, software and hardware available, scalable, very cost effective, a perfect backend to a Weka solution, also applicable to any kind of operating environment that uses S3, such as a backup environment. So if you're, for example, backing up servers using Veeam or Rubrik or Commvault or Veritas, we would provide an ideal backup environment for that kind of application as well.
So this is a public case study with TGen, who is one of our publicly known customer. And what this talks about is our ability to handle the BCL to FASTQ runs in terms of parallelism or in terms of concurrency. So we were able to demonstrate almost an 6x improvement in terms of runs per hour with this particular pipeline, over an existing vendor. Okay, so that kind of showcases a little bit into the capabilities, what we can provide to solving some of this IT challenges pertaining to these pipelines. Yeah, with that, Jen, I think we should be able to wrap up.
Perfect.
Yeah, go ahead.
Awesome. I'd like to thank Shailesh and John for their time today and to our audience for joining us as well. So our first question is, how much GPU acceleration and AI penetration do you see for the life sciences workflows?
Yeah, I can take that, Jen. Yeah, so as I talked about, we are seeing a great deal of inflection happening with GPUs, and we call it, GPUs as well as there are FPGAs. The example I gave was the Edico Genome example. So these are extremely, parallel kind of compute layers, and they are increasingly being used for secondary analysis, particularly. Also, we see AI ML being used across all of these use cases, what we talked about, whether it be next generation sequencing, whether it be cryo EM pipelines, whether it be acceleration of your molecular dynamics applications, whether it be clinical diagnostics. So AI ML is increasingly being used, and we call this as an augmented intelligence category, right? And what that means is there is human supervision and human intervention as and when required, but for the most part, the tedious tasks, the tasks which can be automated are primarily delegated to AI/ML pipelines.
Perfect. Thank you. We do have some more questions. The next one is, why use S3 compatible object storage versus traditional standard NAS? Why would you do that?
The biggest issue is the back end needs to be scalable, right? You have to have an environment that can grow within a single namespace. Traditional storage, you're going to be talking about multiple storage environments with different namespaces, and that's going to greatly increase the complexity of managing all that information and searching it. Searching for data across 10 locations is infinitely harder than looking in a single location. And then the second thing is the cost. Those storage environments were built with different priorities in mind. Object storage was designed to scale at cost effectively, and so it's going to be a third the cost. So those two things, growing in a single namespace and keeping the cost down, are really the two reasons why you'd use S3 compatible object storage.
Perfect. Thank you for that. The next question is, how do you arrive at your 70% cost savings figure?
So the cost savings figure is really derived from two things. One is that the back end, the Cloudian storage environment is built on industry standard hardware. So there's nothing unique about the hardware we're built on, and that was done very purposefully, again, to keep the cost down. So we're using the lowest cost storage environment that exists. And the other thing that's really exciting about that is as you grow the environment, you're continuously buying the newest technology to go in. So in other words, you're not taking old technology and adding on to it over time. You're actually continually refreshing your environment with new technology. And what that means is that the cost continues to decline because you can continue to capitalize on improvements in that technology. So it's industry standard hardware. It's all software-defined storage, and the cost actually declines over time as you bring on newer technology.
Perfect. Thank you for that. Another question, what kind of performance can you expect from an 8-node cluster?
Yeah, so I think that's pertaining to the file 8-node cluster. So I'll talk to that. So you would expect almost 65 gigabytes of throughput on an average just across those 8 nodes. And the beauty of this is a scale out solution. So you keep adding nodes and your throughput and performance will keep increasing. Okay, so you add another 8 nodes, you will get another 65 gigabytes of throughput, all the way up to several gigabytes and several exascale of storage.
Perfect. Thank you. Another question from the audience. All storage makers say they're scalable. How is Cloudian different?
Yes, so every storage maker is scalable and within the confines they normally talk about, which is petabytes would be a normal kind of way to talk about storage. What's unique about this environment, of course, is that your requirements can frequently go way beyond petabytes, and that's where the normal storage environments break down. Cloudian was built on object storage technology, which was designed specifically to solve the problem of scale, the way the data is addressed, what's going on underneath the hood, and the way the addressing works has no fundamental limits. That's not true for block storage. That's not true for file storage. They both have underlying limits in how much data can be directly addressed, which means that if they're going to scale, they have to add on some kind of additional layer that provides a band-aid to overcome that problem. With object storage, there is no band-aid. The underlying technology was designed to scale essentially limitlessly, and that means that we don't have to add on any other layers to manage different kinds of storage architecture within a single system. It is one system all working together right out of the box, no additional complexity added.
Perfect, thank you. Another question, are you running any promotions for COVID diagnosis?
Yeah, I'll take that, Jen. So yeah, we are offering, this is actually in AWS, so you can kind of test the waters and also use it for your advancements with COVID-19. But we are offering 90 days free license for Weka, as well as 90-day credits in AWS. So again, reach out if you have any more questions around it.
Perfect, thank you for that. And then another question, how can we get started if we're interested in this solution?
Well, I'll take it from the Cloudian standpoint. I mean, the easiest way is to go to Cloudian.com, click on free trial, and you can get started today for free. We can set you up with a software load in your own environment that you can run on any server or VM you have. You can get started today. Just go to Cloudian.com, click on free trial, and you're good to go.
Perfect. Again, I'd like to thank Shailesh and John for their time today and our audience for joining us as well. That's going to conclude our webinar, How to Accelerate Genomics Data Analysis Pipelines by 10x with Weka and Cloudian. Thank you for joining us, and we will be following up with you guys shortly.
Thank you, folks.
Thank you.